Right, that is given. The sketch and the operation. So look at the operation. When I press the start button, P is going to cut the groove. It touches switch 4. Q moves up. When it comes at the top and it touches switch 1, P goes back, cutting the bottom groove. It closes switch 6 and Q goes back to finish the job. I give you that operation. The first thing, before you can do any design, you must understand the operation. Read it, check it on the sketch, make sure it's correct. Now, I'm going to write a question here. There are 4 questions. Always the same 4 questions. So I'm going to put it here with the first example in full, and then I'm going to tell you in the next example, and the next example, and the next example, the same 4 questions. The first question is always, give the logic order. Question 2, identify all inputs, comma, outputs, and storage requirements. Three, assign standard addresses. And 4, draw the ladder diagram. With addresses. That is always the 4 questions. And I will show you now that we do question 2 and 3. Don't try and do them separate. We do question 2 and 3 as one answer. Right. Firstly, before you start, check the drawing. And on the drawing, mark which switches are closed in the beginning. We're not going to use it immediately, but mark them. Which of those switches are closed in the beginning? To see that, you must understand what is not shown on the drawing. What will close switch 4? This cutting tool when it comes out there. What is closing switch 6? There is an arm here. There is an arm there. Cylinder P is back, so that arm is pressing switch 6. So switch 6 is closed in the beginning. Although it is normally open, it's normally open, but it's pressed. When cylinder P starts moving, it's going to go open. Right? What is closing switch 1 and 5? Again, an arm that is connected there. Where is cylinder Q? It's at the bottom. So it's pressing against switch 5. So switch 5 is closed. Although it is normally open, all of them are normally open, but it's pressing it, so it's closed. When will it go open? When cylinder Q starts moving up. And then this arm will move up and it will close switch 1 when it comes to the top. You've got it? Right. So I just mark what is closed in the beginning. I'll show you just now why that is important. Now, we come to question 1. Question 1. Give the logic order. Where do I get that from? I get that from the operation. I press the start button. And what happens if I press the start button? P is moving left to right. So P is moving in that direction. What will happen then? You can see it from the sketch and it's written here, it's going to touch switch 4. What must happen if it touches switch 4? Here it says Q moves up. So Q is going to move up. And then what's going to happen? If it Q moves up, it's going to open switch 5 and then it's going to touch switch 10, switch 1. So it's going to touch switch 1. What will happen if it touches switch 1? Touching switch 1, P must go back to cut the bottom groove. P goes back. What will happen if it goes back? It's going to close switch 6 again. And then what happens? If it closes switch 6, Q comes back. And the job is finished. That is the logic order, the answer to question 1. The logic order. Now, we come to what I said here. Switch 6 is closed, switch 5 is closed. Do you see switch 5 there? No, so it doesn't matter. Okay? Do you see switch 6? Yes. Now you must look at this and say, what is the job of switch 6? Switch 6 will make Q go down. Right? Where is Q in the beginning? It is down. So then there is no problem. In that case, this doesn't exist. There is no storage requirement. We check that switch which is closed in the beginning. Does it remove power or does it apply power? If it removes power, no problem. If it applies power, we will see it in the next example, then there is a problem. Okay. But watch. Before I carry on, I could change this operation. and say, when you press the start button, Q moves up. When it touches switch 1, P moves in and it first cuts the bottom groove. When it touches switch 4, Q goes back. And then when it touches switch 5, P goes back and it cuts the top groove. So the operation doesn't have to be the one in the book. It can be different. And you've got to watch it. Okay? We will see that in the next one. Now, what is the next step? Question 2 and question 3 I do in 2 tables. I've got input, address. I've got output, address. This is question 2, that is question 3. So I do it in one together. Right, where do I get the inputs from? I get it from here. Okay, the first input I've got is the start button. The next input I've got is switch 4. The next input I've got is switch 1. The next input is switch 6. What about switch 5? It's not part of the logic, I don't include it. Okay? It's not included. Right. There are the inputs. Now let's look at the outputs. I've got one output, P. There it is. P. Cylinder P. I've got another output. Cylinder Q. There it is. Cylinder Q. People, you can also see it from here. Output, the things that do work. This thing is moving the cutting tool. This thing is pushing the job up and down. So the things doing the work is cylinder P and Q. Those are the outputs. The switches, start button, switch 4, switch 1, switch 5, switch 6, they are the inputs. But switch 5 is not in the logic, so I don't have to include it. Right. Now, what about the addresses? What does input addresses start with? I colon. So all of these are starting with I colon. They are all starting with I colon. And the output addresses, they start with O colon. What comes after the colon? Rack number. Right, I first want to ask you a riddle before I do this. Listen carefully. I've got something at home. It's big and square. On top, there are 4 round black spots. In the winter, I cook food on them. In the summer, I hang it in a tree. What is that thing I'm talking about? That I've got at home. You want me to repeat? I've got something which is white and square, and on the top there are 4 round black spots. In the winter I cook food on them. In the summer I hang it in a tree. What is that thing I've got at home? Somebody said it. Who said that? Who said it's a stove? What is a stove?
Why would you think it's in a
Why
tree?
do you think so worried? Huh? What's wrong? Hanging in the tree. It's my stove, I can do with it what I like. Okay. Now, why I told you that is when it comes here to the design. After the I colons, after the O colon, you get the rack number. It's your design, you can use what you like. The rack number must be what? 00 or 01 or 02 or 03. Okay? What rack number do you want to use for the input? 01. All four of them? Why not? Your boss is not going to like you if you change and you use different ones, because every input card costs money. Huh? You will pay for it. No, he's going to say your design is bad. You just want to use one input card. Right, because how many inputs can I have on an input card? Yes? Was a question this morning. No, they asked you how many output, just fetch an output card. How many inputs can you have on one card? 16. How many inputs do we have? Only 4. So we can put them all on one card. So where do you want to put the card? Rack 01. Okay. Rack 01. Rack 01. Rack 01. Rack 01. In which slot do you want to put it? Slots goes from 0 to 7. Which slot do you want to use? 4. Okay. Slot 4. Slot 4. Right. There I've put the rack in the slot. Now after that I've got a / and then a terminal number. This is a suggestion. You can put it on, there are 16 terminals starting with 00 to 07, 10 to 17, right? You can use any of those numbers, as long as you don't use the same terminal for one input, as long as it is written in octal. So I don't care, I just check if it's valid. A suggestion, not a prescribing suggestion, just a suggestion. If you don't want to get confused, don't call switch 1 terminal 7, call it terminal 1. So I'm going to put here switch 4, I'm going to put on terminal 4. Switch 1, I'm going to put on terminal 1. Switch 6, I'm going to put on terminal 6. Start button, any number you haven't used. Yes sir, which terminal do you want to put the start button? 00, okay. Put the start button on 00. Right. Now I must assign the addresses for the outputs. Can I use rack 01 again? Yes, if I use a different slot. Can I use slot 4 again? Yes, if I use a different rack. Okay, but you cannot use 014, but you can use any other combination. Right, which rack do you want to use? 01 again, okay. 01, 01. Which slot? Slot 3. And now, / any two valid octal numbers. 02 for P, and for Q, 06. Don't put 07 or 08, sorry, 08 or 09. I try to catch you out in the test and exam. I call that switch 8. And then people are putting their 0.8. I'm catching you out in the exam. Okay. There I've answered question 2 and 3. That is question 2 and 3 at the same time. Okay. Now we must do question 4. Draw the ladder diagram first and then put the correct addresses on that ladder diagram. The ladder diagram. Where, how are you going to determine the ladder diagram? We look again at the answer of 1. People, that first answer of the logic order is the most important thing that you must get right. Because we are doing this from there, and we're going to do the ladder diagram also from there. So, what do we start with? We look at our 2 outputs, P and Q. Let's start with the control of P. What puts the power on P? Start button puts the power on, isn't it? What removes the power from P? What makes P go back? Switch 1. So I've got an output with one thing putting the power on, something else removing the power. That is a latch. So I'm going to draw it here. We've got normally open, normally closed, output, latch. There is a relay latch. This is the one that puts the power on, that is the one that puts the power off, that is the output, and that must be the same. So, what is putting the power on? Start button. So that is the start button. What address did I use for start button? I colon 014 and we write the terminal number down there. That's the start button. You can write there if you want to start, but that doesn't matter. That's the start button. What removes the power? Switch 1. What is the address of switch 1? I colon 01401. That is switch 1. What output am I designing? Cylinder P. What is the address of cylinder P? There it is. O colon 01302. O colon 01302. That is cylinder P. So I have designed the logic for cylinder P. Now I must design the logic for cylinder Q. What puts the power on Q? Switch 4. What removes the power? Switch 6. So that is another latch. So I draw another latch. This is the one that puts the power on. So that must be switch 4. Then I look here. What address did I use for switch 4? I colon 01404. That is switch 4. And the one that puts the power off is switch 6. So that is I colon 01406, switch 6. What output am I designing? Q. O colon 01306. O colon 1306. Now, all ladder diagrams, not in the lab, here in class, where we use the full big PLCs, end with a line that says end, so that it will know it's finished. And we number them 0, 1, 2. That is the full design. When I mark, I first give you marks there. Then I check that you identify the equals. Then I check, are you using valid addresses? Do the addresses not clash? Then I look at, are the designs correct? Have you used the correct addresses of the design? And then I check if there's an end line. There's an end line. You don't get any marks for it. But I subtract a mark if it is not there. Any questions? People, we're going to do this 4 times. I've done it now for this machine. I will do it for the machine drilling 2 holes. And then I will do 1 or 2 with totally different drawings. It's important that you understand the machine and the operation. Check the operation if you can follow it on the machine. Check what is closed in the beginning. Then use the operation and write down the logic order. Right? After that, you write down the inputs, you write down the outputs. From where? Input, 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 input. Output, output. Then you add the addresses. Then you go back to the logic order. And you say, right, I've got 2 outputs. I don't care if you turn these 2 around, as long as it's logical. I've got 2 outputs, P and Q. To do the design for P, I check what puts the power on, what removes the power. To do the design for Q, what puts the power on, what removes the power. That is 2 latches. So you just draw the 2 latches. And now you must transfer the values correctly. So if you are designing P, that is the address of P. Then, that is what puts the power on, what puts the power off. That is cylinder Q. That puts the power on, that removes the power. Finished. This question is in every test fee. It is in every exam paper. Any questions? Now. Right, I just want to show you do that one now, we will do it next year, but let me just show you. If I said that when I press the start button, P moves up. Then the logic will be start, P moves up. It will touch switch 1. Then Q moves up. Then P cuts, because now this is on top, so it will cut the bottom groove. P goes in. Then it will touch switch 4. And then I say Q goes back. Q goes back. Then it will touch switch 5. And then P goes back. So now in this case, which switch is not there? Switch 6 is not there. So that list of the inputs will be start button, switch 1, switch 4, switch 5. The outputs will still be P and Q, but there's something I left out. Switch 6 is close to the beginning, it's not there. Switch 5 is there. What is the job of switch 5? To make P come back. Right? Where is P in the beginning? It is back. No problem. So the design is going to be similar, but there will be switch 5 here instead of switch 6. And the order will be Q is controlled by the start button and switch 4. That's Q. And P is going to be controlled by switch 1 and switch 5. So it's going to be 2 latches again, but the addresses will be different, people, because it's a different order. The top line will be the control of P. The bottom line will be the control of Q again. But P is controlled from the start button and switch 1, not the start button. Okay, sorry. There. Q will be on top, and then P. And Q is determined by the start button and switch 4. That will be start button, switch 4, and Q. And you can use any of your own choice of addresses. Do you see that it will be the same drawing? This list will be different. So there will be different addresses.